everyone. Welcome back to another exciting day in mathematics. Whoop, whoop. Warm-up 103 should come up on your screen as soon as you log in. Today we're moving on, so stay focused. We do have a lot of formulas to add to our toolbox. Oh yes, we got this. All right. Get that warm-up done. Copy and go. All right, here we go. Aleshka, what you get for mu? $10. Hands if you got 10. Looks about right. I need a variance. Variance. Pass someone. That was good. Who? Amelia, what you get for variance? What? Okay. Does he help her out, Logan? What'd you get? Variance? What? 21? All right. And standard deviation. Let's go with Aaron. Approximately 4.8. So we are at 14.8 or 5.2. So that's the norm from 5.2 to 14.8. Now we need a z-score for the number 13. Z-score for 13. Pass someone. David. .59. Looks about right. It's a little bit more than half going towards the 1 standard deviation. And what does that mean specifically? Tell your neighbor, people. What does that mean in regards to that number 13 for the z-score? What does that mean? Pass it to someone, David. Santi, what does that mean? What does that mean? 13, the z-score for 13? That it's in the norm, yes. Send that in, please. Copy the agenda. Warm-up 103 is done. Discrete probability distribution. Page 272, numbers 1 through 4 only tonight. Like I said, we don't have a lot of time to be lost in our thoughts, people. Focus. Today we are moving on. Man, it's pouring outside. What's going on? Bah. You guys like the rain? Yeah? Yeah. These days are like, I really need to like really push forward because I work with solar power. So, one of those. All right. You got the agenda? Yes? All right, copy the code to access the home plate tonight. DLF25. 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 All right, so last night was to study your formulas, right? All right, share with a neighbor, let them know how much time you spend studying those formulas because we're going to add to them today. Turn to your neighbor, let them know. All right. And get a Cornell note ready, please. We're about to move on. I can define and compute the discrete probability distribution. I can define and compute the discrete probability distribution. Get a Cornell note going, please. All right, here we go. Before we move on, remind your neighbor, what do they mean when they ask you to create a probability distribution? Remind your neighbor, what does that mean? When they ask you to create a probability distribution, does that mean? All right, what does that mean, Carter? A table. But specifically, what's so specific about that table? Share with a neighbor. What's so specific about that table? Let's see. Austin T. What's so specific? Yeah, the probability is equal to 1. So, this is where we've been so far. We know our classical versus empirical versus subjective probability. We're good. From there, we talked about variables, and we are in the middle of discrete and versus continuous. And we did a couple of days, plenty of practice for that. All right, and then from there, we said probability distribution, and it looks like a table. There it is. And we said that the probability portion, the bottom portion, should equal to 1, as Austin T says. He's on the ball. Let's go, Austin. I see you. All right. Well, today, since we already know how to make our probability distribution, we need formulas to use with those. So write these down. Go to the back of your notebook. We're going to add to our formula, since you guys studied last night a long time, and write these down. Woo, 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 let's go. Oh, yeah, we got this. All right, and as you're writing them down, we need a name for them. Let's start with the first one. Austin T. Pass on one. What is the name of this one? Cole. It's mu, and what does mu stand for, everyone? Mean, that is correct. Takes us to this one. Tell your neighbor what that is, and Cole's going to pass someone. All right, good communication. Cole, pass someone. Brandon Daugherty. Variance, that is correct. And last but not least, that one, pass someone. Mel. Yes, standard. Standard deviation. However, don't we have formulas already for all those? Yes. But these, you're going to label them specifically for what? Look up. For what? Probability distributions. For probability distributions. For probability distributions. So anyways, weren't they giving out like cupcakes in the morning? Yeah? How were they? Pretty good? Yeah? Okay, good. All right. So, now that we have our formula set, let's go to our notes again and copy this problem, please. Example Q. It says, construct a probability distribution for rolling a single die. Compute the mean, variance, and standard deviation. Write that down, please, so you can have at least one example complete on your notes. Hurry up, please, hurry up. All right, here we go. Let's get started. Since you already copied the problem. And it reads, construct a probability distribution for a rolling a single die. So, let's see. Let's start with the probability distribution. Remind your neighbor what that means. What does that mean? What does that mean, Mia? What is it? A table. All right. So we got X. Oh, yeah. X. P of X. All right, so for rolling a single die, so tell your neighbor what goes on top to get started for a single die. All right, what goes on top? Pass someone, Mia. Araceli? All right. So far so good. And tell your neighbor what goes underneath people, and then Araceli's going to pass someone what goes underneath. Araceli, pass someone. 1, 6. So 1, 6 all the way. So since this is a probability distribution, remember we need to indicate that the probability has to add up to what? The sum of 1. 1, 6 plus 1, 6 plus 1, 6 plus 1, yes, 1. Okay, so for this problem they want us to find the mean, variance, and standard deviation. So let's start our formula first with mu for the mean. So mu, and I'm going to have someone read that to me, please. Pass someone. Angelique, pass someone. Brandon Darty. All right. Read me the formula. Ooh, I like that. So the sigma symbol is the sum, okay, of, you said x times the probability of x. Woo. Let's go. So, let's write it out. Let's see. We need to add all the x's times their probability. So let's start with the first x. What is my first x? 1 times, what was the probability here for 1? 1 over 6 plus the next one, 2 times 1, 6 plus 3 times 1, 6 plus 4 times 1, 6 plus 5 times 1, 6. Thank you, sir. Plus 6 times 1, 6. All right, let's continue. 1 times 1, 6 is 1, 6 plus 2 times 1, 6 is 2 6s. Or can we reduce 2 6s, guys? 1/3, yes, that is correct. Plus 3 times 1, 6 is 3 6s. What is 3 6s reduced? 1/2. Plus 4 times 1, 6 is 4 6s. What is 4 6s reduced? What is it? 2/3. Plus 5 times 1, 6 is 5 6s. Plus 6 times 1, 6 is 6 over 6, which is 1. Mu. All right, let's start adding stuff. Let's see. What is 1 6 plus 5 6s? 1. What is 1/3 plus 2/3? 1 plus, we have a 1 over here, plus, and then we have this one right here. So what is our mu, everyone? Our mu is 3.5. All right, from 1 to 5, I'll come to argue with finding the mu or the mean. All right, a lot of 5s. All right, good. So once again, you are given a table. What do? You multiply the top number times its probability for each of them, and then multiply them, add them, and that's how you find your mean. All right, next, let's go to variance. Variance. I need the formula first. Brandon, Darty. Well, before Brandon passes it over, tell your neighbor the formula for the variance. Make sure they understand each component. And then Brandon's going to pass someone. Cole, read me the formula, please. The sum of bracket x to the what? Power of 2 times probability of x, close bracket. Take away mu, or the mean, squared. Yeah? All right. So let's follow this formula. Here we go for the variance. We're going to start with the sum of now x squared times its probability. So let's start with the first number. What is the first number? 1 squared times its probability, which is 1/6, plus, what's the next number? 2 squared times its probability, plus 3 squared plus its probability, times its probability, plus 4 squared times its probability, plus 5 squared times its probability, plus 6 squared times its probability. Are those all the numbers in our probability distribution? Yes. And then minus mu squared. What was mu, guys? 3.5. Once again, you guys have calculators, so you can go a little bit faster than me. There we go. Variance. What is 1 squared? 1 times 1.6. What is 2 squared? That's 4 times 1/6. Plus 3 squared is 9 times 1/6. 4 squared is 16 times 1/6. 5 squared is 25 times 1/6. And 6 squared is 36 times 1/6. Minus, let's see, calculators calculate. What's 3.5 squared? I'm waiting. 3.5 squared. What is it? 12.25. That is correct. All right, let's continue. Variance is 1 times 1/6 is 1/6. Plus 4 times 1/6 is 4/6, or 2/3. 9 times 1/6 is 9/6, or 1 1/2. Is that correct? Yeah? Yes, Mr. Q. Plus 16 times 1/6 is 16/6. That means that's 2 2/3. 2/3? Let's see, 16. That's 12, 4, yeah, 2/3. Plus 25 times 1/6 is 25/6, or 4 1/6. Plus 36 times 1/6 is 36/6, or 6 minus 12.25. Variance. See, let's put this together. Let's see, 1/6 plus 4 1/6, that's 4 2/6, or 4 1/3, right? Is that correct? All right, next. 2/3 plus 2 2/3. That gives me 3 1/3. Let's go, Q. Oh yeah, we got this. Then I got, let's see, 6. Yeah. 6 plus 4, that's 10 1/6. Then bring down the 1 1/2 minus 12.25. Are we doing good? All right, so the variance is 10. All right, so let's put this together. This is 7 2/3 plus, this is 11, and make this into sixes, so that's 3 6s, 4 6s, or 2/3, yeah? Yeah. Minus 12.25. So the variance is 18. 2/3 2/3 is 4/3. So it's 19 1/3, or 19.3 minus 12.25. All right, I'll wait for y'all to give me a number. What's our variance? 19 1/3 minus 12.25. Like Dielli's got it. Very good, Dielli. Bring it over here. How about Mel? What'd you get, Mel? Brandon, what'd you get? What? Should have gotten 7 point something, no? 7 point what? 0.5? Approximately? Or 0.8? 0.8? I'm going to do 0.8. There it is. All right. And now we need our what? Standard deviation. Tell your neighbor what to do. What do we do with that? What do we do with that, everyone? Yeah, do the square root of what? Of the sum of x squared times its probability minus mu squared. So our standard deviation is approximately square root of 7.08, which is approximately what? 2.7? All right. All right, so the mistake was that I had used that one twice, but here we go. We corrected that. 7 and 7, 14. 2/3 plus 1/2. 2/3 plus 1/2. 2/3 plus 1/2. That is 4 6s plus 3 6s is 7 6s, which is 1 1/6. So that's 15 1/6. So now 15 1/6 minus 12.25. We should end up with 3 point something, right? 3 point something. Calculators. What do we get? 3.09. All right. Square root of 3.09, guys. What is it? 1.75? Approximately 1.75. That's our standard deviation. All right. So yeah, be careful when you're doing your computation as you're getting smaller and smaller here for the variance, because it's going to come up. All right. Let's go move on to this one. Copy this one, please. Example 1. Copy the probability distribution. You already sent me your notes for that previous one. Just copy that one. Should go a little bit faster now. Yeah, you do need your calculators, like I said. So this probability distribution for X, we have 0, 1, 2, 3, 4. For their probability, we have 0.18, 0.34, 0.23, 0.21, and 0.04. All right, so mu is the sum of X times its probability. All right? So now that you wrote that, I'm going to give you a little bit more time to finish writing it out, and then I'm going to have Austin T. get us started with the mu, the process. All right, here we go. Tell us what to write, Austin T. No passing. This one I just want to make sure that each one of you know the process of what you're going to be doing. All right, here we go. So, according to the formula, what do? We just did one on our notes. What do I write? Tell me what to write. Zero times 0.18 plus times plus and plus times 0.04. All right. So mu, 0 times that is 0. 1 times 0.34 is 0.34. Plus 2 times 0.23 is 0.46. Plus 3 times 0.21 is 0.63. Plus 4 times 0.04 is 0.16. And of course, you add all of those with your calculator. And what is our mu? Pass them one. Austin. $1.79. Hands, have we got 1.79? Is it 59? Okay. 1.59. All right. Okay. Hands, have we got that? All right, so now that we have that, let's go to our variance. Variance. Our formula is the sum of, now in bracket, we got x squared times p of x, but then we were going to subtract the mu squared. All right, tell your neighbor what to get started for that one, and then I'm going to have Cole pass it to someone. Very similar to what Austin T did over here, by the way. All right, pass someone, Cole. Brandon, tell me what you write. 0 squared times 0.18 plus 1 squared times 0.34 plus times 23 plus times plus times 0.04 minus 1.59 squared. All right? So the variance, this is 0 times 0.18 plus 1 times 0.34 plus 4 times 0.23 plus 9 times 0.21 plus 16 times 0.04 minus 159 squared. Somebody, 159 squared, what is that? What is it? 3.5? 2.5? 2.5? 2.5 what? 2.528? So let's leave it at 0.53. So the variance, this is 0 plus 1 times 0.34 is 0.34 plus 4 times 0.23, that's 0.92 plus 9 times 0.21, that's 1.89 plus 16 times 0.404 is 0.64 minus 2.53. Variance, let's see, calculators calculate. 0.34 plus 0.92 plus 1.89 plus 0.64. What is that? What is it? Is it 379? Yeah? Minus 2.53. So my variance is 1 point what, guys? Approximately. 26? And of course our standard deviation is approximately, what do we do at the end with that number, guys? Square root, so therefore, what is it? 1.1. Not bad, not bad. All right. Now, there's other types of problems that look like this one in regards to you need to create your table, but I'm not going to go over this one. It's very simple to set up since we already know how to set up our probability tables. However, I'm going to go straight to the home plate for tonight. Look at the home plate. It's only 4 of them to find the mean, variance, and standard deviation. So, turn to your neighbor or team up with someone and divvy up that work. So like that, you only do 2 of them, right? Those of you following on YouTube, make sure you get that practice in. I'll stop right there. And I'll see you guys next time. Peace.